Hello, listeners. Welcome to another episode of The Circuit. I am Ben Bajarin.
Greetings, Internet. I'm Jay Goldberg.
Apologies in advance for our sound for two reasons. I'm traveling at Amazon's reInvent conference, so my mic did not make it. And so audio is what it is. And Jay was having some technical problems. So we're on our AirPods, which sometimes works, sometimes doesn't. But bear with us as we go through this episode. Um, so today, one of the things that I've been thinking a lot about, and so I'll sort of tee up this conversation as it relates to, let's say, consumer products, is, for lack of a better term, the pursuit of technology exploration. And so, what I mean by that is companies or companies who take chances with products, and those products seem interesting, but at the same time show the limitations of where we're at in the semiconductor cycle, especially with things like miniaturization, and then even things all the way to kind of some high performance compute like EVs. So I'll sort of throw the first example out, right? And the humane pin, I think, is an interesting thing to look at within this banner of technology exploration. They're breaking new ground. They're trying something new. And we shouldn't discourage that, because we want to see people try new things in the hopes that from those early efforts, we find some things that are super interesting. That being said, it's a little clunky. The user interface is not quite there. It's a little bit underpowered. And that, as an example, in my opinion, shows just, again, a challenge of the limitations of the silicon where we're at in something that's small. But my point, Jay, is we shouldn't be like, well, you should never have tried it. Even if it fails miserable, I want to encourage this exploration. But the main silicon point here is, I think it just really shows the limitations of where we're at in really small semiconductors.
Yeah, so I had a very similar emotional journey around the humane pin because the company has been teasing something for 6 months now, which always makes me skeptical when companies do that. Um, then they launched, and there were a lot of like just problems with the way that they launched it. Their
Mm,
messaging was just confusing. It was a lot of defining what it wasn't. It wasn't a clear message. It wasn't well delivered. And my first instinct on looking at the product was like, oh, this is almost laughable. Like, what is this screen on my hand thing? Like this, like there were so many problems with it. But then very quickly, I was like, no, hang on. Let's not jump to conclusions. I don't have to buy this product, and good for them for trying this. Like,
right.
this is not the right product. It has a long way to go, but full credit to them for rethinking this, because I think like phones are boring. Like, we all have phones, they all look the same. Is there a better way to do this, right?
Yes.
And until the day we get neural implants and it's all wired directly into our brains, are we going to have something in between neural implants and our phones? Is there another device in there? Nobody knows. The humane pin is making a is it's a you know it's a good concept. So
Yeah.
full credit to them for that, but maybe work on your messaging a little bit.
Well, messaging, and I think, again, I would imagine that people who try it early will also say similar things like, "This was really interesting. Hadn't experienced this before in terms of a mental model. This was not great," right? So it's part of an evolution. But I similarly kind of trying to backtrack from just poo pooing it, which
Right.
candidly I think comes from the fact that you and I have been around the block in technology several times, and I just seem to find it like the more you've been doing this, perhaps the more cynical you get on things where there is technology exploration, just because you realize it has a long way to go. But it's a novel, and I think we should applaud their approach, while at the same time recognizing that, like, this idea or this concept 5 years from now, computationally, in terms of where silicon will be, miniaturization, performance per watt, all of which it can do, will be very, very different. So it's great that it's early, but what can we take away from that that showcases, future experiences? The other example I have for, I know most of our people are listeners, but should you watch the video, I'm wearing the Meta Ray-Bans that they Meta worked with Qualcomm and Ray-Ban to create, which has a couple of things. They're essentially just glasses and or sunglasses. I have the transition lenses, so I don't need spectacles, but I'm wearing them inside and outside. So I've been walking around this conference taking video and pictures of screenshots with my glasses. But my personal favorite is this kind of audio experience that they have, where built into the bridges in the over the ear here is a surround sound kind of spatial audio experience that creates this little bubble where you hear this fairly immersive audio experience, but you can still hear ambient audio. So I've compared it to very much AirPods in transparency mode in terms of quality. You hear your ambient environment, but you still hear, your music, which we know a lot of people, when they're walking in the city or jogging, do want to hear their environment for a safety reason. But it's very hard to explain until you try it, but it's super compelling, this kind of personal audio bubble that you get for things like phone calls. I'll listen to music when I'm just walking around the show floor here. But that being said, it showcases here again the limitations of this technology, because is there enough value if you don't need glasses to wear glasses all day? I wouldn't, because they're uncomfortable and I don't like it. But all they do is take pictures, and those pictures again are better in quality, but not super great. And the audio is really good, and we're kind of distilling to those two things. So, is there foreshadowing of where this can go? I mean, I think we believe there's value in face-worn computers, but we're so far from this, and they last 4 to 5 hours. There's very limited compute in it, which again just shows, in the design of these things, we don't have these really tiny, very powerful processors yet to deliver that. So again, just an interesting example of, I'm glad that there's technology exploration here, but again, you run very quickly up against some of these limitations, which is also a limitation of where we are in technology, and in a lot of cases, the semiconductors.
So for those of you who can't see Ben right now, his glasses, they're Ray-Ban, but with clear lenses, so not sunglasses. They look okay, but they also are definitely the kind of glasses that if you were at a 1950s high school, the jocks would beat you up.
That is exact. In fact, I think my grandpa in the late mid 1900s had these exact same glasses. Like they are very geeky. So you are on point with that. But they're also kind of the standard Wayfarer design, but a little bit thicker. Basically, I guess how I'd describe it.
How do they connect to the internet? Bluetooth or
through your
cellular?
phone? Yeah. So
Through your phone.
There is an AI assistant in it. I can just say, "Hey Meta," which I'll do now, and it'll make a little sound. And then you can use it for basic control. So audio up, audio down, change song on Spotify. Basic searches. It knows the weather. It knows some general context, but it's not a fully rich large language model or AI assistant. But you could kind of see where that's going with a smart assistant in your ear at all times, I guess. But again, very limited by how much they can put in this really tiny frame.
Yeah, I think it's very interesting. There's a lot of design choices and room for improvement that can go into these glasses. I mean, this is Facebook's third version of these glasses. They keep pushing it, right? And so for me, like one of the things I always think about when I see these glasses form factors is the shape of chips. Like 99% of semiconductors are square or slightly rectangular. I think for glasses, if you're going to put it in the stems, you need very long, narrow chips, which is very non-traditional for semiconductors, but it's certainly something that's technically doable. It imposes certain design limitations, like your, pin counts. Some of those things get kind of weird.
Yeah.
But if it's limited functionality, like why not try it that way? And I think we're going to see. And again, that's something we've just never done before. Let's try it out and see what it may
Right.
yield some interesting advances.
Right.
Um,
Well, and this, like the AI pin, and I think that's an excellent point because you don't know that until you've tried to build it. That you're like, oh, I got to design a different size because it doesn't work, right? Even the way that the camera sensors integrate in here, right, or generate, like you until you've tried it. And I will say, I tried the first version of these because this is version 2, and these are much better. But again, very, very a far way off from where this goes. But you got to try these things to really figure out where your limitations are and what you need to do different in the future.
I agreed, and I think what's like everybody else, I've been buried with AI news lately, OpenAI, all this stuff. Uh, then we had NVIDIA's results out last week, where a big topic of conversation, at least among investors, was edge inference, right, or inference for NVIDIA. But that leads to the topic of edge inference and where is that going to take place? Like, how much inference for AI can we do on device? And I think something like glasses is a really, really interesting case study because, like, these glasses get much more powerful and useful if you can actually fit some kind of slimmed down AI
Mm-hmm.
model into them to do inference.
Mm-hmm.
We're probably still pretty far from that, given,
Yeah,
but
super far.
it's not never. It's 5 years,
Right,
right?
right.
Because the models are shrinking and getting more efficient, and the silicon is advancing. So I don't think it takes that long. I think it's something that we'll have. It's not. I'm not going to wait for my grandkids to show it to me. I think you and I will be able
Yeah,
to enjoy these things.
right. No, no, agree. I mean, I would say we're just maybe conservatively, this is a 10-year arc. You're up against design capacity as well. Just we don't have wafer capacity for existing compute, let alone what happens if I'm going to start shipping 100 million smart glasses a year. I don't know how we solve that problem, but I think those things compound, and yes, right over the arc of those 10 years, it gets there. Um, but like I said, I like that we're trying these things. I personally, people will probably fight me on this because they did on Twitter yesterday when I tweeted it. I've actually modified my opinion on Meta in that I actually think for what this is and for what Quest 3 is, it's actually really good hardware. Like there are some very impressive hardware and software experiences. And from Meta's case, they're investing in these hardware and software things that we believe will be someday. Like they're not trying to go backward and make smartphones and PCs. They're trying to make smart glasses and mixed reality headsets, etc. And so I think at this point, and again, this isn't one of my, this isn't a strong opinion strongly held, but at this moment in time, I actually think Meta may be the primary competitor to Apple in next generation consumer hardware like glasses, spatial reality headsets, etc. Because I've had such a positive experience with some of these things so far that have led me to sort of take their hardware efforts more seriously, I guess is my point.
One of the things that happened when Apple launched the Vision Pro, when Vision Pro launched, there was a lot of dunking on Meta about like, oh my goodness, look how awesome Vision Pro is, and look how janky the Quest looks. And Zuckerberg actually posted about it. I think a fairly long, I think it was a blog post, maybe just a very long tweet, saying Apple has done us a favor. They've validated that this market existed. We've looked at everything they've published about it, and they haven't discovered anything secret here. We could do all the things that they do. We're just coming at it from a different
Yes.
design choice path. And he got dunked on that a lot because just that's the way the world is. But I actually thought that was a pretty good take, right? He's saying, like, from an engineering standpoint, there's nothing magical about Vision Pro. They're just going to, they're going to charge an arm and a leg for it. We're going to keep doing it. We're going to do a cheaper version, and of course, the functionality will be different. Um,
Yeah.
but that's okay. We'll meet in the middle somewhere and the market still needs to mature. And I think that's a pretty valid point. And and it's interesting to me that they keep pushing on this. I think I still don't quite understand why they're not doing their own silicon for it, but and why they're in particular why they're not doing their own operating system for it. But fine, um, they have a good partner in Qualcomm who seems to be helping them
Yeah,
along.
right. Well, and I think relative to this category too, I mean, I think we've got these two things, which both make the same points that we're saying, with the caveat that a mixed reality headset like Quest 3 and Vision Pro, despite how expensive it's going to be, when a person uses it for the first time, will feel a much more mature technology experience than with these glasses and with a humane pin. So you're going to try that version and you're going to feel more use cases and value day one than you will some of these things that I think are further out the technology exploration path, like humane pin and these Meta Ray Bans. But within that context, it's still really early. You know, you try a mixed reality headset today, and my perspective from both of those is that it truly is the mixed reality experience that's going to help this go from a pure, call it gaming enthusiast category, to have more people start using it, especially in a productivity context. But again, we're up against the amount of compute we can put in these headsets and the peripheral sensories, how long the battery lasts. I mean, again, right, at Vision Pro, I think I'm forgetting it lasts 2 hours on that integrated battery block. I mean, it's running an M2. It's doing sensor fusion for a bunch of sensors, like really hard compute. It's going to kill the battery. So as valuable as that might feel day one, we're again really up against these limitations of just what we can do with silicon and the available components in form factors that are that compact, right? Not a giant PC with 15 inches or so of space, or a smartphone that doesn't need that level of compute.
I always harp on this topic of software. Like software is really what determines the utility of a lot of these things. And I think what's fun to me about exploring all these new devices is that we're at this point where the software experience on all mixed reality devices is largely undefined. We
Mm,
don't know what the software is going to look like. We don't know what people are going to use this for. Is it just going to be movies? Is it just going to be gaming and porn, or is it going to be something work based, or all of the above? Like we
right.
just don't know. And what's fun about that though is we're trying to chart two things here, right? We're trying to plot out software capabilities, but the software people are trying to plot out what the underlying hardware can do, and finding a place where that sort of those two meet and equilibrate is going to be the real challenge of all this. Because
Mm-hmm.
today there's not a lot you can do software wise. Your phones, your sunglasses don't do AI. The Vision Pro has terrible battery life. Um, but developers will eventually figure out, like, oh, with these devices we can cram this on, we can do that, we can figure out that, and that's how we're going to determine how that's what's going to determine how successful all this is when the software ecosystem finds a sweet spot for power performance trade offs and start writing code to that. But
Yeah.
they need the chips to start improving to get there.
Right.
Much, and it's much more undefined than anything else in technology today. Like we
Right.
understand, like everything else is sort of a trade off. It's just is a constant grind. A little bit more tops, a little bit more flops, what have you. This is trying to find an unknown. Uh, we don't know where we're headed exactly, and that makes it, I think, more interesting, at least to
Yeah.
me.
Well, and that's why I think it fits this idea of, this stage that we're at right now, that's rapidly progressing, but technology exploration, and a lot of this is uncharted territory. And in that, you learn a lot of these lessons, and companies try, companies fail, there's adaptations. It's technology gets into its awkward stage, like we all were when we were teenagers. It's not a baby, but it's not grown up. It looks really weird. It's just an odd duck. But I think my point is, like, we talk a lot about, like, well, what's coming next, right? What's after the smartphone? And this is the progress that has to happen. This is the weird innovations and the technology exploration to get there. Like, you don't just go from I've got a smartphone to I've got the craziest cool smart glasses the next year. It just doesn't happen. Like this is the progression we're on. So, you know, observe it and I guess.
There we go. That's the title for this episode is Awkward Teen Years.
Technology's awkward teen years. But so you point, let's segue now, that this also applies to automotive, which I think is a good point. So elaborate on that.
Yeah, so before we were recording, we were talking about what are the interesting areas of innovation in semis and hardware. And to me, the really big glaring one is what's taking place in automotive semis, especially what's coming out of China, right? Because there is clearly a shift in buying patterns, in consumer purchase decisions. Consumers everywhere, and they're buying cars, they care less about speed and torque and horsepower and more about the UI of the car, like what the car interior looks and feels like. Other things are still important, range, specs, still matters. But this sort of current generation of cars, people care a lot about that interior user experience. They want it to look a lot more like their phones, right? They want it to be app-like. And so we're starting to see a lot of trial and error in China's electric vehicle EV space, right? Right. I don't know if you've looked at it, but you look at some of these new Chinese EVs, and they're crazy inside. I mean, they're beautiful. Even fairly inexpensive price models have a really distinct design aesthetic.
Yeah.
That makes them look fancier than their price point would indicate.
Right.
And that applies to the software too. Not all of the software really meets sort of American tastes for software. Like user experiences in China and US tend to differ a little bit, but still some of them have really, really interesting, compelling features in them that are fun. And, and of course there's Tesla too, right? Tesla has all kinds of new features in its cars that are software enabled that nobody had tried before. Right? There are all these over-the-air updates that are possible. And just the basic user interface in these cars is really different. And a lot of this is coming because the Chinese EVs in particular are coming at this from a place of, we're going to start with the software. These are smart cars. That's a term I hear more and more, smart cars.
Yep.
Software-defined cars is another term we hear a lot. And it's really changing the driving experience.
Yeah. Well, and what's true though is, so it's interesting because, I hadn't thought about it also in this context but I think it makes a lot of sense, right? Outside of a Tesla, which I really do feel like when you get in that thing, you're like, this feels like a whole different car, especially if it's your first time coming from a traditional vehicle to a Tesla. But even within that, right? 5 years from now, again, and Tesla's doing their own custom chips. In fact, we forgot to mention that even in our last episode about people doing custom, that Dojo is actually a super interesting chip that they're developing for the reasons that they verticalize to solve problems that they believe merchants aren't solving. But in doing so, they hit these bumps, right? It's not where it's going to be in 5 years. And so we're still up against the limitations of current technology, even with automotives, which I think is an interesting parallel path in discovery. You could argue, as nice as those cars are, we're still in that it's not quite there yet stage relative to the full scope of what this computer on wheels is going to be, 5 years from now.
Yeah, I think for me, one of the sort of telling things about this is we recognize that cars in the near future are going to need some sort of processor, some sort of CPU equivalent, but we don't have a name for that yet, right? Because everybody's still trying to figure it out. Even as we have Qualcomm getting all kinds of design wins for Snapdragon in the car, they don't quite have a name for it. I mean, nobody's calling it the automotive processor unit, which is, I think, where it's going to end up, the APU, right? But
APU means something though already. It's an application processor unit. It's got to be something else.
It's also a name, right? It's APU, so
yeah. Automotive.
It won't be the first duplicative acronym out there. But my point is that we're still defining what that is, right? And everybody still seems to have a slightly different take on what's going to go in that chip, and that's part of the debate.
Yeah.
right? Because another function of this is it's not just the UI that's getting software defined. It's also a lot of the drivetrain. Right? You and I have talked to a bunch of microcontroller companies recently, right? Who are all rethinking their role in automotive semis and trying to bundle multiple, sell systems rather than discrete chips for things like steering and power control and sensors, right? All those little things. And if you start to tie those into a centralized processing unit, whatever we're going to call it,
Right.
you're going to see real meaningful improvements in car performance. I think we're going to have to do that, integrate the tires and the drivetrain into the central processing unit of the car to really, you'll get a boost of range if you can do that well. But all of this is like super undefined. And so why I keep coming back to the subject of Chinese EVs in particular is the fact that there are 75 of them, right? There,
Right.
something like that. There are several dozen Chinese EV makers who are all going at this problem, tackling it slightly differently.
Mm.
And this is a function of the Chinese development model where they just throw lots of competition and see who wins. And I think part of that means we're seeing a lot of experimentation. We're seeing a lot of trial and error in this space with more people coming in the market all the time. Like we have Xiaomi, the big phone maker in China.
Right.
They're very close to, their launch and their vehicles. And I think so much of what we're talking about here is going to depend on what's possible in the silicon.
Yeah.
And it's a different design challenge than for your eyeglasses or for headsets because miniaturization is less of a problem. You have a lot more space to deal with.
Sure.
But you still have you have meaningful power constraints, right? Because you don't want the processing in the car to like hurt range of the vehicle. And there's a lot more going on that you have to be able to do all that sensor fusion. I mean, we could end up with a pretty sizable processor
Yes.
running all these cars, and never mind autonomy. Just before even before that, and I think one way to do it is you have companies like Humane who are just like pioneers and you're going to get a lot of arrows in their back, trying out something really really different. Another approach to that is have 75 car companies each doing slight incremental tweaks and experiments, which gets you to whatever the final model is. And I think that's, again, it's one of these things that makes covering the space really interesting right now, is to see that experimentation.
I think that's your size point is an interesting one because just in the spirit of this technology exploration, if that's true, and I do think it is, that we need bigger solutions, then advanced packaging is going to play a role in automotive for supply chain. And within that, we have a very immature advanced packaging situation right now with the market, which will get better over the next 3 to 4 years, right? Drive economies of scale. Let us make wafers, right? Or chips in package that are, bigger than 150 by 150 because they're doing those for the data center. And so that maturity of advanced packaging probably then plays a role in some of these ability to design these bigger chips, which again, to our point, you wouldn't know unless you tried it. So you got to learn by shipping, to use Steven Sinofsky's blog's name. But then you identify those problems, then you know what solutions you can look for. And I think advanced packaging might be one of those things.
I think it's even broader than that because in all of this discussion, we've talked about usually when we talk about automotive semiconductors, we talk about things on trailing edge processes, right? Right. Microcontrollers are all way older, way more mature process than 16 nanometer even, right? Mm-hmm. You don't need anything more than that. Once you start talking about a processor, though, there are real advantages to keeping it at something advanced. Maybe not 3 nanometer, but probably 5, right? If you're to do it today,
at least
you want to be pretty close to the leading edge, which is a big change for the auto industry. One of the big sticking points in automotive silicon is auto qualification, like getting auto qualled. There are all kinds of rules, ISO, whatever, I forget the numbers. There are all kinds of ISO certifications you have to go through in order to get that. And once you start talking about doing that with an advanced process chip, and then that, of course, entails advanced packaging, that stuff all has to work in cars. It has to be humidity and pressure and temperature hardened, sensitive, because that's what cars have to go through, right? It has to be able to sit out in the sun and be able to go over rough terrain and get bumped a lot, which is not something anything in the data center has to deal with.
Yep.
And so those are some big challenges. I don't know how you do advanced packaging and keep it auto qualified. That's going to be a big lift for somebody.
Interesting. So I just had a random thought as we were talking about this. What if the customer that for 18A that Intel seems to keep saying is like going to need a lot of chips is Tesla? Why are you laughing?
Sure, why not? Well,
I don't know.
All right, so I think it's somebody else. I think it's somebody else. Could be.
Yeah.
I think if it were Tesla, Elon would have leaked it by now.
Because
unintentionally.
He can't keep anything secret.
You can't, right? Yeah. Two, I don't know if you saw, there's a big headline this week. Tesla actually just bought a whole bunch of H100s, like a lot of H100s, like 10,000 H100s.
For the back end, though, not for cars.
No, because Dojo isn't just a chip. Dojo is a supercomputer.
Yes.
Right, and so they're buying a bunch of H100s to plug in next to their own chip. I don't know exactly what's going to do what in all that. Yeah, it's a big number, right? And so, yeah, Yeah, let's not talk about Elon.
Yeah, interesting. But this does, though. I again, just in the grand scheme of solving this problem, right? Advanced packaging capacity at some leading edges in some of these areas might be a play where Intel and IFS is going to get some value once we work out these things. We get through this awkward stage and we start scaling in high production of more complex processes. Tesla's just an example. Tesla's just an example that they maybe someday I could see him saying, "Yeah, we want to make them in the U.S. Rah rah. Let's work with Intel." Like, I don't know. I have no clarification. I was just spitballing. But anyway, all right.
We should start a betting pool on that customer.
Moving. I mean, it's just, yeah. All right. I don't know. Okay. Well, let's wrap there. Good discussion. Actually, if anybody has any other thoughts of like techno exploration that we've missed and wants to chime it in, send us an email or hit us up on the Twitter. I'm curious if that analogy makes you think of another category. But anyway, for now, good chatting, and remember to like, subscribe, all those things, and we will talk to you next week.
Yep. Thank you, everybody. We'll be back next week, but then we're heading into the holidays. We might have a limited schedule. So thanks for listening. Tell your friends.